Hello everyone, it's 1 p.m. Eastern, and that means it's time to begin another of our monthly CoCoRaHS Weather Talk webinars. Thanks for joining us today. I'm your host, Henry Regis. Behind the scenes with me today, running our program is Zach Schwalbe here at the Colorado Climate Center at Colorado State University here well, it was sunny, but now it's cloudy, Fort Collins, Colorado. For those of you who are unable to join us for our live broadcast, we'll be recording it for future viewing on our website. All of our Weather Talk webinars are sponsored by grants from NOAA's Office of Education and the National Science Foundation. Today we look at a subject that you don't hear much about, and that's the history of meteorology. Many of us know much about the science today, but are often puzzled, where did it all come from? Well, we're excited to have with us today Jim Fleming. Jim is a professor of science, technology, and society at Colby College in Waterville, Maine. He's written many books. Those include Meteorology in America from 1800 to 1870, The Calendar Effects, Fixing the Sky, and then today he's working on a new book which includes works on Harry Wexler, who we will speak about today. Jim is also an alumni here of Colorado State University, and I had the privilege of hearing him speak last year on meteorological history at the Atmospheric Science Department's 50th anniversary last summer, and it was really great. Jim, welcome. It's great to have you with us today.
Well, thanks, Henry. It's a really great pleasure to be with you all. And the list that I saw was so impressive, reaching all the way across the country, maybe even internationally.
Well, Jim, your screen should be popping up here shortly. Just click on that, and we should be ready to go. And we'll go on silence here in the background, let you take it away, and we'll be back at the end of the broadcast for questions. Thanks again, Jim. Appreciate you being here.
Well, thanks, and hi, everybody. I'd like to talk about some work I'm doing on a book called The Emergence of Atmospheric Science. And I've been working quite a bit with the documents and papers, and even with the daughters of Harry Wexler, who have his family papers. Harry Wexler is probably the most important atmospheric scientist you may never have heard about, because he was ahead of the research in the Weather Bureau through the 1940s and 50s, died young at age 51 in 1962, and he was like a kid in the candy store because he had all kinds of new opportunities and technologies and ways to look at the weather in higher dimensions and in 3 dimensions. So I'd like to talk about why he got to the cutting edge and how he got there, cutting edge of research, and how his story might fold into a larger story about the emergence of atmospheric science. So I'm going to run through a couple slides here and just do a little bit of storytelling about Wexler. Wexler came out of Harvard University with a math degree, and he was born in 1911 and took his degree at Harvard in the 1920s and came out of there in 1930. He didn't know what to do with his math degree until he went down the street a little ways to MIT and had a chat with a fellow named Carl Gustav Rossby. Now, Rossby is a well-known name, and he's going to factor into this story as I go along. But Rossby was Wexler's mentor, and basically in what is said to be about a 20, 30-minute interview, convinced Harry to go into this new field of dynamic meteorology that was really not even a department yet at MIT, but it was just emerging as a new program under the Aviation department. So Harry went from Harvard to MIT and worked there with Wexler. Harry went there and worked with Rossby. Here's a picture of Wexler as a young man, and he was said to have gotten into the interest in the weather through his physics teacher, who would teach him things about the physics of the atmosphere, also ideas about physics of sports. He was interested in sports. Wexler's brother-in-law was Jerome Namias. They were both from Sharon, Massachusetts, and they both married sisters, so they were very close throughout their life. And Jerome Namias became sort of a legendary figure in the quest for long-range forecasting, while Harry developed all of the programs of the U.S. Weather Bureau in a very important age of satellites and digital computing. Also, Harry was a paper boy, and he was able to brave the weather every day and go out and deliver his papers. And so he mentions that in one of his little autobiographical sketches. There is no biography of this person, and I was lucky to get this kind of photograph from the family. This is one of the family photos that I've been able to use in my work. If we look at the situation of meteorology circa beginning of the 20th century, we have the famous Vilhelm Darkness in Bergen, Norway. He's not in Bergen yet, but he does write a paper in the Meteorologische Zeitschrift. And he says there's two things we need to make a forecast of the future state of the weather. And that would be, number one, a sufficiently accurate knowledge of the state of the atmosphere at the initial time. So those are the observations. And two, a sufficiently accurate knowledge of the laws according to which one state of the atmosphere develops from the other. And so he took a look at the laws of hydrodynamics and thermodynamics, and one of the emphasis on this slide is the word sufficient, because you'll never have a perfectly accurate knowledge of the state of the atmosphere. And I know you're all weather observers and you take careful measurements, but the network is not 100% dense, and there are outlying observations. And so there's this situation where Darkness was aware of this limitation, and he basically built his program for mechanical and physical meteorology based on these two criteria. Now, this continues. He was working, as I said, in Norway. So this is just a placeholder image of the nation of Norway, but it's conveniently located to the east, that is, you'd say, downwind of the North Sea. And so the North Sea, the Norwegian Sea, provides the source region for a lot of the things that Darkness was interested in. And so if we look at the observations, he began collecting exclusively surface observations, and in some cases observations from the fishing fleet off the coast of Norway. But observations, as one of his disciples, Tor Bergeron, tells us, observations were not sufficient to lead to a forecast. They were the beginning point. They were essential. They were absolutely necessary. But what was needed was the weather analysis, the tools that were needed to smooth the observations into fields in which you could apply the physical laws. So you'd have missing observations. You'd often also have to smooth these things into temperature, pressure, moisture, kind of isopleths, and begin an analysis. So that one of the famous books in this field is called Weather Analysis and Forecasting, and the tools of analysis, the objective analysis, is absolutely essential in moving this project forward. Bergeron's account of this history also says then, well, of course, Darkness came up, and his son, Jakob, and Bergeron came up with a model, and that's the famous air mass frontal model along the polar front. And as I mentioned, this is an open wave cyclone representing their model. I just sketched it in there. But it represents the idea that there is a way of patterning these smoothed observations into models that would allow for sequential forecasts to be made from something like this. So I'm interested in Wexler, who was an American, and I'm interested in Rossby, his mentor, who moved here to America. And moving this kind of a model, this is a very interesting model, but moving it to the United States, and down below here now we have a map of the U.S., this was a daunting task. It wasn't simply to move the model and bring it over from Norway and apply it to the situation in the United States. Because, as I indicated, we sketched in the coastal mountains, the Rocky Mountains, the Appalachian Mountains, and all of the influences of the Gulf Coast and the Gulf Stream and the onshore flows that make the United States really a very complex weather analysis situation. And so the Bergen School had many disciples and many people reaching out, coming over to America and other parts of the world. And in every case, these ideal models had to be contextualized for the geography and the situation at hand. And here's another example. This is from a textbook example. This is the publication by Darkness and Bergeron. showing the classical open wave cyclone model with the cold air and the warm air sector, cold front and the warm front. But applying that to a U.S. weather map, this is a U.S. weather map from 1933, you see all sorts of features on this map which are not as classically clear as the open wave cyclone coming across the Norwegian Sea. We do have a low pressure system. We have apparently a hurricane, a tropical air mass, and they're using a different kind of nomenclature for the different air mass conditions on this map. You still see some highs and some lows, but it's a very complex and messy situation. Now, the standard histories of the Weather Service say that this was because the U.S. Weather Bureau was very recalcitrant, very backwater, very slow to adjust. But actually, in 1928, Rossby had come over, and that's about the same time he met Wexler. These fellows, along with Horace Byers and others, were trying very hard to bring the Norwegian methods into the Weather Service. So the history of the Weather Service, or the history of meteorology in this case, depends on whom you read. If you read the directors of the Weather Service, you get what I sort of call well, let me put it this way. If the history of meteorology is the 100-acre wood, you end up with Eeyore as the weather director saying, oh my, how are we ever going to get this done with our limited budgets? And I think you all have heard, at least in the cartoon version of Winnie the Pooh, the voice of Eeyore. And this is a kind of a task that's very burdensome, to put together a complex analysis by hand and to try to make charts and maps for the daily forecast. But if you're somebody like Wexler, who's into research and using mathematical techniques and looking at the new opportunities, I think you're more like the Christopher Robin type. You're looking at all the possibilities, and you're looking to go out and have, in a way, fun and insights into this new situation. So I'm going to tell you about how these observations and techniques and technologies and models evolved throughout the 20th century, and how it made meteorology and weather forecasting into this larger interdisciplinary field we call atmospheric science. So it's a tangled story. It's tangled because there are no reliable full-scale histories of the 20th century in meteorology. And it's tangled also because of these different voices, the voice of Eeyore and the voice of Christopher Robin. And there's many, many good short biographical sketches of people and short accounts of different offices and activities. But what I'm trying to do in my work is untangle some of these short strands and make them into a kind of a longer braided strand that could be used to weave a tapestry out of. Here's finally a picture of Rossby. This is from the personal collection of Wexler's descendants. And so it was a snapshot that Harry took of Rossby, and I think it's in a European city. And he's very jaunty. He's very bon vivant. He's smoking his pipe and looks like he's about to have some kind of new idea, because Rossby really was an idea man, and he really was an organizer. And those are the two ways that we remember him: as an organizer of the MIT program, later the Chicago program, later the Stockholm program, and as an idea man who brought us the notion of hemispheric Rossby waves and other good things. And so it's this Rossby-Wexler connection that interests me, and I'm going to go forward to talk about the technologies of the 20th century. I think what you need to have under consideration when you're thinking of meteorology is that it really is a technology-based science. There's a picture of Marconi in the upper left, radio. We would not have an electromagnetic 20th century without the ability to send and receive radio waves. And so if you think of the role that radio plays in meteorology, obviously they move from pilot balloons to radiosondes. And so we have a picture there of micro miniaturized radio transmitter down on the right-hand side being launched on a balloon, hopefully with a recovery parachute below it, and then a fellow able to receive radio signals from a distance. And it's this ability to do remote sensing that I think is really the sine qua non of technology for the 20th century that eventually leads to our abilities and capabilities in outer space, because it's a way of getting remote messages sent and received across great distances. And the meteorologists immediately saw the implications of radio, both in miniaturization and instrumentation, but also in broadcast. And so radio broadcasts of the weather began in the 1920s on some stations. I think KDKA was one of the first. So this is one of the technologies that really Darkness did not have in 1904 when he was thinking of his observations. He was thinking mainly surface, mainly a network across Norway at the time, with some hope that it could be more universalized. The next technology really that drives the 20th century is the aviation. And so the needs of aviation were again adapted to meteorology. This is an image of a U.S. Navy plane out of Anacostia, and under the wing, tucked into the wing with a red arrow pointing to it, is a wing-mounted aerometeograph. And these were spring-driven instruments, barometric pressure, temperature, humidity measuring devices that ran on a roll of paper ran through as the airplane flew. And pilots were given a premium to see how fast and how high they could get. And so they tended to fly pretty much daredevil vertical patterns as much as they could, although the atmosphere, it was best served, it turned out to be later, by the radiosonde balloons that goes up through the layers. The pilots would then level off and fly along a level surface, and that gives you some information, but you had to wait in this case for the pilots to come back down and give you the instrument so you could take the paper scrolled up off of it, and then you would have to reconstruct the record of the flight. So aviation, this is just instrumentation of using the airplane, but the needs of aviation were also pressing and driving the need for a better ability to forecast. This is with the airmail, this is with the beginnings of passenger flight, and it's with the use of the airplane for military purposes. So there's two themes in this, in all the technologies. There's the commercial use, and there's also the military need. And so society is driving a lot of this development and the meteorologists they're not just hitching a ride, they're actually designing the new ways of using these technologies very, very quickly. As soon as something comes on commercially or invented in some other realm, like in the military, we'll talk about V2 rockets in a minute, but as soon as something comes available, there's a kind of a smart meteorologist thinking of some way to use it to gain information about the atmosphere. Another social need was World War II, and of course meteorology played a role in World War I. I passed over that a bit, but in World War II there was a pressing need for a worldwide, basically extension of Air Force around the world in all kinds of theaters, in the polar regions, in Burma, in the Far East, over Europe. And so there was a crash program at hand to train World War II weather cadets. These are relatively highly educated recruits. Maybe they have a bachelor's degree or almost a bachelor's degree in some technical field. And they were given a crash program in weather dynamics and atmospheric physics and then techniques of launching weather balloons and making forecasts. And the big program ran at University of Chicago. That's where Wexler was asked to move after he received his PhD from MIT. And Wexler during World War II was a major and eventually reaching lieutenant colonel in the Army Air Force, training weather cadets as his assignment. He ended the war at the Pentagon as the liaison for all weather information and services from the military back to the Weather Bureau. So this was a very large program. These people could sign up, they could pass some tests, and they could take classes and be sent all over the world to do theater-based forecasting. And Rossby was very good at that too, the mentor for Wexler. Rossby would travel the world and basically adjust meteorological theories for tropical purposes, for Far Eastern forecasts, and basically he contextualized the basic principles of atmospheric physics into ways of forecasting in different regions. And so during World War II, they started the tropical meteorology program at Puerto Rico, and that became the foundation for tropical meteorology, with people we know like Herb Reel being one of these students. Okay, and here's again, Rossby came over as one of the, directly studied with Bjerknes and came over to the U.S. as one of the sort of the people bringing the Bergen theory, the Norwegian fronts and air masses, to the Weather Bureau. He had a tank. This is not the tank he had in the basement of the Weather Bureau, but even in 1928, he had a rotating wave tank. What I guess we call them now Rossby tanks. And this is the one from Chicago, but he had it rotating and differentially heated, so it would be heated by coils on the outside and cooled by ice in the middle, and then a kind of a colored fluid you'd set the speed of rotation so you could set up kind of standing waves in the tank. And he was studying these things because he was not totally bound to the air mass and front model of the Norwegian school. He was thinking hemispherically. And so a Rossby wave is one of about 4 or 5 standing waves in the upper atmosphere, let's say about 300 millibars, moving along and possibly defined in some ways by the jet stream, moving at the boundary between cold and warm air. And these Rossby waves were his vision circa, before 1939, but by 1939, he had defined a kind of a hemispheric circulation of the atmosphere, a larger model, sort of a capital M. If Bjerknes's model was a model of a storm, this was a model of the hemisphere and the upper air then shaping and in a way directly influencing the surface weather. So in this case, you would expect, it looks like you might have a trough over the Rockies somewhere near Colorado, and you might have surface low pressure developing in response to some of that up above. So the history of meteorology is still following this model of innovations through new technologies, new techniques of smoothing this into and applying this so that the math and physics works out, and then the model, the big M. This is the Rossby model of hemispheric circulation. So tools, techniques, technologies, I put under T now. Observations are getting higher and higher. They're getting faster, and they're getting definitely a three-dimensional scale to them, so we can go up beyond the bottom of the troposphere. And then the models. The model of Rossby waves was one of the big contributions, the conceptual model. Societal needs I mentioned, and that is the need to have good flying and safe landing and forecast for aviation, the need to do that for military needs in World War I and II, and other sort of social needs that were coming up through the needs of commerce and agriculture. And so I call this my STOMP model, S-T-O-M-P. That's my aide de memoire there. That's the acronym for people coming in, because what is history without some warm-blooded protagonists? And so we need to have not the full biographies in my case, but I need to give flesh out their careers and show why they chose the kind of things to study that they did. And so I have a STOMP model of tools, techniques, and technologies combining and smoothing out the observations, extending the observations, and interesting people coming up with new models, but all in the context of societal needs. And so I'm playing with this. I'd be happy to have any of your feedback on this or insights as we wrap this presentation up. So here's a picture by 1956, Wexler and Rossby sitting on a boat together at Woods Hole in the harbor. And what they were doing was developing basically the MIT Woods Hole dynamics program between the oceanographers and the meteorologists. They were beginning to think by 1956 that this field that they had called dynamic meteorology was now including so much more that they needed a neologism they call atmospheric science. So the word atmospheric science comes into the vocabulary, pretty early in the case of the British, but in the U.S., the National Academy in 1956 begins to talk about the Committee on Atmospheric Science, replacing their former Committee on Meteorology. And they began adding new people. They began adding oceanographers and mathematicians and chemists and all kinds of people that could give them more insight into the fluid dynamics of the planet. Okay, World War II was not just a crash program for education, but it was a great time for new technologies. This is Harry Wexler's brother, Ray Wexler's photograph from the Signal Corps station in New Jersey, taken during World War II, of a small front, a weather disturbance off the coast of New Jersey, taken with this new technology called radar. And they began to discover very quickly, it was top secret at the time, you couldn't say the word radar. If you have any World War II classified documents, the word radar is always blacked out. And so this was a new technique to try to probe and find enemy planes, and radar was one of the great new innovative technologies of the war, but it was also applied to bouncing radar beams off of clouds and off of especially hydrometeors. So you could see precipitating clouds, and this became one of the new inspirations for Wexler to work with as he transitioned out of the war. He was moving from the Pentagon to the Weather Bureau as head of research in the Weather Bureau. So here's a fellow who was trained in the Bergen School, had brought some air mass analysis to the U.S., had trained all the people in the war effort with others, and then was moving into the cutting edge of new technologies. So I'm going to run through a couple new technologies like the bomb. You don't often think of the bomb as a weather instrument, but outdoor atmospheric testing. This is a Nevada test, but the stuff in the Pacific and the atmospheric outdoor testing was leaving all sorts of radioactive tracers in the atmosphere, which allowed for the radioactive materials to be followed around the planet. So you could see these waves in the atmosphere. You could see the effect of a detonation in Nevada was having on its trajectories going around the world. Another technology, another social pressing issue was air pollution. As we turned the corner into the 1940s and 50s, a lot of air pollution events happened. This happened to be the Donora smog event in the industrial town of Donora, Pennsylvania. And Wexler was on site studying this basically as it was happening. So bad weather in this case didn't come from a low-pressure storm system. This came from a persistent high-pressure system that gave them an inversion over the mountainous valley around Donora. And this, also, I forgot to mention, he was not at Trinity, the test of the first atomic bomb, but he studied the pressure waves from the first bomb, and he wrote a paper about the effect of the bomb on the atmosphere right as it happened, 1945. So he was definitely at the cutting edge of everything happening. His portfolio was full of all the kinds of new technologies and social needs that meteorology was coming up against. This is an outline of a weather proposal produced by the researcher Zworykin at RCA Laboratories. Vladimir Zworykin is known as one of the patent holders for television. He was a very brilliant inventor, and in 1945 he wrote an outline of a weather proposal that suggested there could perhaps be a perfect machine to calculate those equations of motion and of atmospheric change ahead of the weather. And if this was possible, then you might be able to actually control the weather if you knew exactly to the minute when it was going to start precipitating and where, or if you knew exactly where a storm was coming on shore. He proposed linking this perfect forecast with a rapid deployment force to go out into the field. This is right after World War II. And to use a deployment force to go out and intervene in weather systems, perhaps bombing nascent hurricanes or lighting fuel oil along the coast to cause a heat deflection of a storm. So anyway, this is a very visionary kind of thing. It circulated through, this is from the Wexler papers in the Library of Congress. And it also got into the hands of Johnny von Neumann, who was a brilliant mathematician up at the Princeton Institute for Advanced Study. And here's von Neumann on the second from the left, with Wexler as his basically right-hand man. And Wexler was assigned to the Weather Bureau as liaison to help get digital computing and what we call numerical weather prediction off the ground. And so for the first couple years, from 1948 to early 50s, Wexler was making monthly trips from DC to Princeton and working together with von Neumann on getting the kinds of talent together that was needed to get this project running. There's his brother-in-law, Jerome Namias, is marked as fourth from the left. This is a fellow I mentioned earlier. And Reichelderfer is second from the right. He's the director of the Weather Bureau. So Reichelderfer was a very exceptionally trained Navy aerologist who came into the Weather Bureau through the path of the Navy and had studied in the Bergen principles at least, and had made a copy of Bergen methods before he came to the Weather Bureau as the director. And yet, if you read Reichelderfer's papers, you'll see that, muted voice of Eeyore saying, oh my, we have to do computers and rockets and radar. He had a limited budget, limited personnel, and so even with his great training, it was his bureaucratic position gave him that kind of a limit that he couldn't really get everything that he wanted to get done. So in this picture, I guess, Harry Wexler's Christopher Robin, because he's still looking at the great possibilities and doesn't always look at the budgets. And Reichelderfer has to look at the realities. Standing next to Reichelderfer on the far right is Jule Charney, another one of the great mathematicians recruited out of UCLA. But it was actually Charney joined the program late, and the program was gotten off the ground by Wexler working with von Neumann. So that's part of the story. It actually, in a way, retells the story that some people know pretty well already. But it also tells the story that computers were not just the holy grail of meteorology. Computers are not the models. Computers are the tools that run the conceptual models. And so without Rossby waves, or without some smoothing techniques, or without some approximations, you're not going to have much of a forecast. The computers are tools, not models. And they're not the only storyline in modern meteorology. It's not just that Bjerknes had to do things graphically, but now we can do them electronically. There's all kinds of other layers that I mentioned already in a way, radar and radio and the aviation layers of technology. Because the next layer of technology is rocketry. These came out of World War II just like radar did. Here's basically a German V-2 captured from the war with an extra stage on top being launched into the near space, really. And so the other story of the 20th century is that the limits become, in a way, limitless as the space age begins. I don't think the space age started in 1957. I think the satellite age did. I think the space age started very early with people like Robert Goddard and early experimenters on rocketry. But also it must have had its roots in the early radio pioneers, because once you get rocketry and radio, you can move onward and upward. In some cases, the V-2 here in 1954, the Arabi rocket had taken a shot over Texas. This is looking, looking at the top of the diagram has a tropical cyclone in the Gulf of Mexico, one that was not known at the time to the Weather Bureau. So this is a mosaic of about 100 individual photos taken by the Arabi. And when they pasted it together, they found the tropical storm. But this is 3 years before Sputnik. And they're realizing very clearly that something could be done here with a space-based program, perhaps with rockets, but eventually with satellites. This is an image of the Earth from space, commissioned, actually inspired by Arthur C. Clarke, who's science fiction writer, very famous. But Clarke is known as one of the Imagineers, I guess you'd call him, of the geostationary satellite. And he asked Wexler to give a talk at the American Museum of Natural History. And he was supposed to give this talk in the 1950s. So Wexler asked his people to come up with a graphic. He commissioned an artist. This painting is actually hanging in Washington, D.C. at the Nestis seminar room in Silver Spring. And it shows what you might see if you were above, in this case it's geared to being above Texas, 4,000 miles in altitude on a satellite vehicle. So you can see open wave cyclones and one coming off onto the shore of the northwest. And you can see, for example, trade cumulus. There's a little tiny blotch of white near Puerto Rico, and this was supposed to represent the beginnings of a hurricane. The kind of hurricane that maybe if you saw it that small and just beginning, you could go out and intervene into the hurricane. So there's a lot of features on here. There's mountain clouds, and there's a marine stratus off the coast of Baja and San Diego and West Coast. And so this was a very imaginative thing done about 3 years before the IGY and 3 years before the launching of Sputnik. There's Tyros 1, the television infrared observation satellite, and they would have cloud pictures that they would then superimpose and try to locate onto the Earth's surface, find out where it was, and they would add, I have other diagrams that show them adding classical analysis of weather systems on top of these photographs and trying to make what Wexler called a storm patrol, a kind of an eye in the sky that would never let any severe weather sneak up on the populace. And so here's another social need. Once you can get a satellite, once you can watch over storms, every hurricane or every severe storm since has been, for the most part, has been observed and mediated through the eyes of the satellite. Okay, so Wexler's career reached kind of an apex, and at one point I guess he thought it was a plateau, when he was asked to be the head of research for the Antarctic programs in the International Geophysical Year. Now, Wexler at the time was working with von Neumann. He was building a global model. He was a Rossby student who was thinking about the world's global circulation. And he said to himself, he had a bunch of sleepless nights. He said, why in the world would I want to get a parka, go down in a military, excursion, basically the Navy was taking them to Antarctica, and deal with some polar explorers that may have some other issues than I do. And so he thought about it for a while. And the more he thought, the more he realized that going to Antarctica and learning about the dynamics, especially the weather and climate dynamics on the Antarctic continent, would be one of the keys to understanding the global circulation. There had been a lot of work done in the northern hemisphere. There has been very little work in the southern hemisphere. And if you think of the southern hemisphere, it's mainly a large continent at the pole with a lot of open ocean around it. So there was speculation that they could even find Rossby waves propagating around the oceanic circulation, circumnavigating Antarctica, and that getting the sort of the Rosetta Stone, the key to the southern hemisphere was Antarctica, and the southern hemisphere then would be the key to understanding the whole atmosphere. So I think what Wexler was really thinking about was even a bigger model, a model of the entire general circulation of the oceans and atmosphere in the satellite era. So you remember, Darkness had done a model of polar fronts and wave cyclones. Rossby had done a northern hemisphere model of hemispheric circulation in the upper atmosphere. And I think that Wexler's goal in taking this assignment was trying to put resources to bear on this issue of global circulation in a new age of instrumentation. Okay, and here he is, smiling Harry with his parka on, and photographed by another famous geoscientist, J20 Wilson. And he made a couple trips down to Antarctica. It was usually in the Antarctic summer. Harry also got CO2 observations going on the top of Mauna Loa. This was a Weather Bureau station. They'd been doing a lot of different work up there, work on atmospheric electricity, on other kinds of trace gases and mountain phenomena. And he convinced basically Dave Keeling to take a fellowship and moved to the top of Mauna Loa with his instruments while he was connected with Scripps Oceanographic, of course. But the carbon dioxide measurements on Mauna Loa would not have been happening the way they happened during the International Geophysical Year without the intervention of Wexler, who was head of research at the time. And here is about four years of CO2 measurements, 58 to 62. This represents the Keeling Curve during Wexler's lifetime. He died in 62. But by 1962, we already knew that there was the clear annual cycle and an upward trend in CO2, moving in this case from about 315 to about 318 or so on an average basis. So, I mean, you start to add this up, with the World War II training, with the weather radar, with the numerical weather prediction and the satellites, and now we can add CO2 to Harry's portfolio. He was really at the cutting edge of all these things. The Keeling Curve now just keeps going. I think my students were telling me we passed 400 the other day, but I don't know if that was an annual wiggle or the average wiggle. I have to look that one up. Okay, Wexler got concerned about human heavy-handed intervention and wrote what I call his Halloween paper. This is 1958 in Science. And he had a little bit of tongue-in-cheek tone to this. He called it modifying weather on a large scale. But he thought that the current weather control, climate control proposals of 1958 were either impractical or likely to produce cures that were worse than the ailment. And so he had some scenarios in here of how to raise the Earth's temperature a couple degrees, how to cool it a couple degrees, and how to clear out the clear out the Arctic Ocean of ice. The Russians have been trying to clear the oceans and by damming the Bering Strait. And Wexler, I think inspired by Edward Teller, again with tongue-in-cheek though, he said, oh, all you need is about 10 hydrogen bombs and you could make an ice cloud that would change the irradiance and the climate over the North Pole. This is a very fascinating paper to read, and it strikes for one of my recent books is called Fixing the Sky, about weather control, and I made quite a lot of headway with that book by using some of this work by Wexler. This is from his papers, and it's an example of his handwriting. And he got worried about whether somebody could cut a hole in the ozone layer and destroy ozone either purposefully or inadvertently. He was well connected with the Pentagon, as I said. And here he has a theory written in handwriting. Ultraviolet decomposes ozone to form atomic oxygen. In the presence of a halogen like bromine or chlorine, then the oxygen recombines and so prevents ozone from forming. Big pause here, slash. Here's the chilling part. 100,000 tons of bromine could theoretically prevent all ozone north of 65 degrees from forming. In this case, he was worried that maybe the Russians would do it or try it, or maybe the U.S. would be thinking about weaponizing something like this. This was 1962. This is the year that the Cuban Missile Crisis peaked. This is the year of incredible tension in international affairs. And Wexler had come up with basically what's called the bromine bomb theory, that something could be done to quickly, catalytically destroy ozone. So he wrote about, he went on a national lecture tour talking about climate control as nothing more than an interesting hypothetical exercise. And the consequences would have to be looked into because they would require colossal engineering, but they would also have inherent risk of harm to the planet or side effects that would counterbalance the possible short-term benefits. He was way out in front of today's geoengineering discussions. And so I'm often involved in geoengineering meetings talking about history, and I like to cite the fact that wise people of the past had warned about this even 50 or more years before. This is again from his papers where he's talking about bromine, breaking into atomic bromine and destroying ozone and giving you bromine oxide. And so the sunlight catalytic conversion came about through his correspondence in his network. He was talking to, in this case, to Oliver Wolf at Caltech. And when I showed this to several very prominent ozone scientists, and they really were very amazed to see that catalytic reactions were known and they were understood back in '62, although this had never been published. This Wexler died that year, '62, and so this came out of his archives at the Library of Congress. Here's my Rosetta Stone, a rough note linking all these different things he was thinking about. I'll tell you about this a little bit. Sidney Chapman was a famous IGY scientist who had talked about cutting a hole in the ozone in 1934. Oliver Wolf was a chemist at Caltech, and Wexler got worried that the oxidizer, the chlorine oxidizer in rocket fuel, might trigger an ozone depletion, even in a small amount. And so 100,000 tons of bromine or a small amount of rocket exhaust, given the ideas they were having for a rocket measurement. They were thinking of using rockets almost as frequently as radiosondes back in the late 50s, early 60s. And so we were going to have a rocket brigade that was going to look into upper air structure. And then Wexler realized that actually that would be very destructive to the environment. Okay, so he ran models. He took the Manabi and Moeller's early atmospheric circulation model, and basically what he did was he took ozone out of the atmosphere and ran the model as an experiment to show that removing the ozone would change the entire radiative equilibrium thermal structure of the atmosphere. So he was very much a combination of observer and innovator and also mathematically astute modeler. I'm going to skip that one to show you Harry showing up at the White House. He was there to get an award. Harry's there with some of the secretaries of the cabinet, and there's two fellows there in the front that are probably the focus of most people's attention, Kennedy and Johnson. But Robert McNamara is on the far left, and Wexler was having these ideas about ozone depletion and possibly weaponizing chlorine or bromine. And so it's very possible in '61 he might have had a conversation warning that somebody might be able to do this and they should look into it. Because right away they did look into it. He did look into it with his colleagues. He was also at that time, that could have come out of his role at the White House, he was assigned to Geneva to begin negotiating what's called the World Weather Watch. If I go back a slide, he was in high diplomatic circles here. He was very highly regarded. He was a career government scientist who, if you remember David Halberstam's book, The Best and the Brightest, the Kennedy administration liked to surround itself with talent. And I think Wexler might be called, in this case, an advisor to the best and the brightest, a technical advisor. Harry actually was called once to go up to Boston to the American Meteorological Society and put his head together with some other people from AMS and write a couple lines for Kennedy's State of the Union address. He was, especially as the space age was dawning, there was this idea that there should be something we could do cooperatively with the Russians, something beside rattling sabers and threatening to annihilate each other. And so Wexler was assigned from that to go to Geneva as the lead negotiator for what became the World Weather Watch. Here he is with his Russian colleague, Bagayev. And he was very much an internationalist. He wanted to see the peaceful use of science. He held the ideals of the International Geophysical Year, that science done by many nations at the, in a field campaign could be a good thing. Wexler got some Russians to live together with some Americans at Little America. He was all in favor of international understanding. And so he thought that what could happen was the shared use of weather data, especially from the two spacefaring nations, that if they had weather satellites, they could share their data with the other nations of the world. And so it was something to do beside basically rattling our sabers. And the World Weather Watch, which began a year after he died, but the World Weather Watch is still functioning and still very much in existence as a UN WMO program. And so the line that he gave to Kennedy was the one about Kennedy got up, and I think it was in Dallas, where he said, we choose to go to the moon and do the other things. And the other things meant share weather data, share share scientific discoveries with each other for the peaceful benefit of humankind. And so Wexler wrote some of the lines that included the World Weather Watch idea in Kennedy's speech. Here he is again with Bagayev, and they're having a pretty good time talking about rocket sondes. These were sondes that would go far beyond the troposphere, up into near space, and carry instruments with them. The key feature, I think, in this whole photograph is the rocket exhaust, because that's where Wexler was getting the concern about having chlorine oxides as rocket oxidizers, and that whole trail of vapor, that whole trail of smoke would be possibly ozone depleting. And so he got onto that project in the 1960s. His legacy, as I said, is really pretty vast, and we just want to give a little review here as we're starting to wrap this up. If we look at what he was involved in from his early training, his first job was air mass and frontal analysis. If you remember, trying to bring Bergen methods to a very messy weather analysis situation in the country. He was in the program in the Weather Bureau for air mass and frontal analysis under Reichelderfer. Then he led a group and was one of the main teachers in the World War II weather cadet training, really crash program, to try to get a lot of people out into the field to make a worldwide support for global aviation. After the war, he rotated into the Weather Bureau, came out from the Pentagon, and became interested in the air pollution issues. He studied Canadian forest fires and the smoke shield they put across the U.S. He studied Denora and its killer smog, and he was on the basically the Atomic Energy Commission's dilution program to see what would happen with reactor releases and plumes. He got into rocket and satellite meteorology big time as of '54. He gave that talk at it was actually at the Hayden Planetarium, and by invitation, and began thinking about the satellite as a vehicle for meteorology. He had never thought too strongly about it because, as he said initially, the satellite is outside of the atmosphere, but it's a really wonderful way to look down and to make continual observations of things like visible clouds. But then very quickly they got the idea of putting on other wavelength sensors, infrared, and other kinds of ways of getting information. He was involved in Johnny van Neumann's Institute for Advanced Study Numerical Weather Prediction program, and he basically then, as head of research of the Weather Bureau, was in charge of operationalizing that by I think it was 1954. We had the 50th anniversary of that in 2004. But the operational numerical weather prediction was Wexler's portfolio. He recruited Joseph Smagorinsky to be the first director of what became GFDL. Also, computer models. Another aspect of this numerical program was to make general circulation models. Eventually they become climate models. And so Wexler's portfolio involved what can the Weather Bureau do to establish a climate modeling program and get that up and running. Then I said, as I said, the International Geophysical Year asked him to be their chief scientist, and he put on his parka and went out to study Antarctica and came back with a lot of insights about how that continent influences, or in some cases very strongly influences, the southern hemisphere. He got Mauna Loa monitoring going for the CO2 program, and he became really concerned about climate engineering, concerned about ozone depletion, and then the year of his death, he had a very large portfolio on his desk, a very large duty to try to get the World Weather Watch outlined. And this is the year of the Cuban Missile Crisis, and he's sent directly to negotiate with the Russians. In many cases, there's a lot of secret communications going on about what our satellites could or couldn't do and what we were allowed or not allowed to release. So he was, in a way, a diplomat by this time. And so this is the this is Harry's, the person is Harry Wexler. The societal needs I've explained to you, and the models have just gotten more and more comprehensive, while the observations need to get more and more detailed and from a higher and different perspective using the technologies of the 20th century. So this history is going to be a kind of a braided narrative of technologies and people and the kind of conceptual models and social needs that were coming together between about 1900 and about 1960. Because in 1960, the word atmospheric science becomes visible as the National Center for Atmospheric Science and the University Corporation for Atmospheric Research and becomes NCAR and UCAR, and they build these architecturally distinct high-MP buildings, monuments really to computing on the Flatirons at Boulder. And so atmospheric science becomes a real thing. I'm not interested in this book going much beyond that. Maybe I'll put a little epilogue on it. But I really want to talk about how we went from Bjerknes's vision of observations and forecasts through the 20th century to the moment when we're seeing the atmospheric sciences emerging in all of their different dimensions. Here's Harry as a mature person, head of research at the Weather Bureau. Lifespan is 1911 to 1962. He died of a massive heart attack on vacation up at Woods Hole, and working vacation because he had the World Weather Watch on his desk with him. And so he's a very admirable person, very important person that maybe not too many people have heard that much about, but I really do hope more people will. And so I was really kind of, as I said, wild about Harry, and I was over at Woods Hole 2 years ago, and we have a picture of him. This is probably him, it might be the year of his demise. He's sitting on a little stone outcrop there near Ile Pond in Woods Hole. And so I poked around. I had a little bit of free time, and I went down to Ile Pond and poked around, and I think I found the same site, although there's a new facility in the back. And the wall is a little bit off to my right, covered by trees now. That bush grew up, and they put a new Woods Hole marine biological facility behind it, so the little houses are gone. But I think that's the same spot. So I was there sort of imbibing the Woods Hole atmosphere and thinking about Wexler, the cutting edge of research, and this thing I called the emergence of atmospheric science. Okay, so I'm gonna end right there, and thank you for your attention. And I could refer back to any slides, but I'll go to that control panel and see what the moderators want to do now about questions. Thank you very much.
Yeah, thank you, Jim. This was very interesting and amazing how one man can play a role in so much of the meteorology that we know today. Quite amazing. We're going to take some questions here, and let's see what we've got. We've got a first question here from Jim in Freeport, Maine, right? Not too far from your neck of the woods. Yeah, Jim wants to know, did Wexler study under Rossby in Norway?
He did not. He met Rossby in Cambridge, Mass. as a recent math graduate of Harvard. He came down the street and found Rossby there.
Okay, and let's see if we have any other questions. Go ahead and type them in now. We've got Jim on here for a little bit if you have some questions on this. Jim, let me ask you one. When would your book that you're working on, is there a date for publication? When do you think that'll be out?
Well, I have a lot of the research in hand and partly digested. And so I have a sabbatical coming up, and I'm just going to sit down and write. And that's one of my goals, is to get this thing out by next year. So I would appreciate that the timing is perfect for this network of weather observers to give me any feedback or questions or something that wasn't so clear, because it'll all go back into my mix, and I'm trying to get this out in a year.
This is Nolan Duskin. I didn't get to listen to the very beginning, but I was fascinated with your presentation. For fellow CoCoRaHS observers on the call, I do want to let you know that we did have a Carl Rossby direct relative as one of the early CoCoRaHS volunteers in Colorado, and unfortunately she died at a fairly young age of cancer and was only in the network for a couple of years, and I never had a chance to ask her more questions about her life and memories of a very famous meteorologist.
Well, I think when you asked me to do this, I was working very directly on Wexler, and since then I've taken up some research on the Rossby life and legacy, and so we actually have a project right now to collect his papers, as many as we can find. So the other warm-bodied, blooded person in this book that's coming out is going to be Rossby. It's going to be the Rossby-Wexler axis of developing atmospheric science.
Well, Jim, maybe we could have you come back next year and talk about Rossby. That might be an interesting webinar for some folks. Hey, here's a question. Another question. Boy, Maine seems to be the place today. Here's from Lubick, Maine. Ruta wants to know, how did you get started, and how did you choose to write? Why did you choose to write about Harry Wexler?
That is a wonderful question. In fact, the last time I gave a seminar in a history department, I had to explain how I got into it. I worked as an atmospheric scientist at Colorado State. I did a master's on modeling cirrus clouds. And then I took the high altitude training, and I was an instrumented observer. I was up in the aircraft going around, in clouds and storms, and we had some very great adventures up there in the sky. It was actually pretty dangerous. I flew in Pacific storms out at the University of Washington, an old World War II era surplus bomber. And one night coming in after a really bad night, we clipped off the top of a pine tree at the regional airport. And the plane didn't crash, but I recall pulling out a 2-inch branch out of the equipment that was slung below the plane. And I decided right about then and there that I needed some other way to engage with the atmosphere, some safer way. I was about 25 at the time. And I got interested in the history of science and technology, especially the history of atmospheric science, atmospheric technology, and the engagement of that with public policy. So after the near crash, and I began to retool, I took a PhD in history of science, and I was able to get into a program that took scientists as well as history majors. And I remember my general exam, I had to write an answer to my own question, which was the final question: what would you write about if you were going to do your dissertation? And I wrote down, I said I would write about the insights to be gained by using the history of atmospheric science as an approach for history. And at that time when I was doing the PhD, everybody was doing Newton, Darwin, or Einstein, or some great individual, usually in physics, sometimes in biology. And when I remember when I answered meteorology or atmospheric science, the junior professor on the panel didn't really go for the answer very much, but the senior professor really loved it, thought it had a lot of potential. So I was able to sort of sit back during my exam and listen to the senior guy argue with the junior guy. And the result was my dissertation that came out, that Meteorology in America from 1800 to 1870. When I went back, see, I knew atmospheric science. I had a degree in it. And yet I used the historical method of going back till I got lost in the detail, and I didn't know what they were doing in 1800. So that's where I started to write the history. And since then, I've been writing about this and weather control and history of meteorology and stuff. But now I feel like this time is right to get into the 20th century, to take that sort of tangled skein of short accounts and in some ways not necessarily misleading, but limited accounts about different things, and put them together into a nice 60-year history of 1900 to 1960. And so I mean that's my own sort of personal approach to this. And the reason I got into Wexler was because I'm always an archival hound. I love to have the original documents. There were 44 boxes of Wexler papers at the Library of Congress. His widow had put them there 6 months after he died, and had never taken. They were basically his office files, never sorted or never taken out, just put in the same order they were in his drawers. And then I started reading them when I was in Washington, D.C. for a year. And at first it didn't dawn on me. I was looking for an article or just a little angle. And then I realized, as I said before, I was kind of wild about Harry. He was involved in everything. He pops up in that, you know, that picture of him in the White House. I don't know if I'm still on the screen or not, but
You are. We can see it.
that picture of him in the White House, he's kind of Zelig there. He's popping up in everything. He pops up, you know, like Woody Allen Zelig, you know. He pops up in the White House. He pops up in the Pentagon. He pops up in the Mauna Loa on the observatory. He pops up in Geneva, you know. And so the more I read about him, the more I realized that I wanted to read, and in many cases I've photographed most of these 44 boxes of documents, so I can work with his papers. Then I realized that his mentor, Rossby, was another one of the great axes along which to write. And so I started thinking about the holidays this year, about Christmas time. I was thinking, I need this keel, this Rossby Wexler keel, if I'm going to build sort of a large, you know, ocean-going vessel. There's going to be a lot of different layers and different decks and different decor on the eventual thing, but I'm not building a kayak here. I'm building a very large story about atmospheric science. And so I added Rossby, who doesn't have any papers, but has a lot of theories in his name and a lot of fame. So Rossby is maybe the most famous meteorologist of the period, and Wexler's the one who was very important but people hadn't heard about. So I'm going to try to link that sort of professor and student together into the storyline.
Jim, I've got a comment here from a person from Jim from, I think it's called Gavrazut, New York, and he just mentions here that Harry's observations and conclusion theories seem very accurate for someone who didn't have the technology we have today. So quite amazing for that period of time. Just making a comment there. We've put on our website, we've got Jim Fleming's books listed, and we're linked to his Amazon page. And if you guys are interested in any of his other books, Jim, could you quickly go over some of the other ones real fast? We have about 5 or 6 minutes left here, and just kind of give folks a taste of what they're about.
Okay, well, Meteorology in America was, a version of that was my PhD dissertation, and that book became pretty much a standard account of 19th century meteorology. But when somebody asked me about it, I said it's really about 19th century America told through the eyes of the history of meteorology, because it's about the westward expansion. It's about the institutions like the Smithsonian before there was a weather service. It's about sort of gentlemen scientists networking together with people from other parts of the country and other parts of the world. So it's very much a combination of intellectual and institutional history of meteorology. And then I wrote a book called Historical Perspectives on Climate Change. It was a bunch of essays, really, on the people like John Tyndall and Svante Arrhenius, and people that were putting together ideas about climate change. And it became one of those labors of love, I guess you'd say, that again, it was a major kind of project for me on climate. I'd moved from weather to climate. In the meantime, I'd edited a few things. One of the most important ones to me was the AMS 75th History book, where we had a lot of the founders of the fields, like Ed Lorenz is in the book, and we had Roscoe Bram and people like that. And then we had students of the founders writing these essays on meteorology. And this thing is sold out. AMS sold their whole print run. And I hear people talk about these essays that an entering graduate student in atmospheric science should read one of these essays just to see where their field came from.
Looks like there's still looks online, there's still a few available on Amazon. I was just looking at that.
Oh, the historical essays is not cheap, though.
No, it's up there. It's up there in the 40s.
Not in paperback, folks. I'm sorry.
Right.
And then the two more, I'll mention two more. One was called The Calendar Effect, and this is Guy Stewart Callender, the British steam engineer, who I did a short biography of him with the AMS publications, and he was a fellow that reinvigorated the greenhouse effect theory of rising temperatures and rising CO2 and infrared radiation in 1938. So I like to find sort of early exemplars of people that were really thinking outside the box. And then my final, most recent book is called Fixing the Sky, The Checkered History of Weather and Climate Control. And that's about rain makers and rain fakers and weather engineers and the kind of, there's kind of a Rube Goldberg side to this. It's kind of a tragic comedy that has some relevance to science policy. So next week I have to talk about, I'm the only historian in a big geoengineering meeting, and I have to convince them that history matters as you're looking to future pressing issues that are facing the planet. So it's a lot. I just had fun. I've been lucky, and I try to stay close to the original sources and get material out of people's letters and diaries and papers.
Well, there's some neat books there. Hey, we got two more questions just came online, so let's try to answer these before we go. Mike in Ohio is a planetary atmospheric scientist, and he wants to know, have you ever thought about writing about the history of planetary atmospheric science, so other planets?
Funny you ask. I have a independent student working on clouds right now, and her paper is called Clouds, History, Myth, and Science. And she started with the familiar clouds, but she's going to write a paper on the unfamiliar. So just the other day we were talking about the big news came about the hurricane-style storm on Saturn, and the way that planetary, what would you call them, astronomers or people that work on planetary atmospheres from the point of view of geophysics, they really have tremendous insight into how the Earth works as well as a planet. And so our thinking was to do this. We might do a short thing on clouds that move from the familiar to the unfamiliar and move outward from the Earth into the other planets that have clouds. And then maybe turn the corner and come back to celebrate sort of the view of Earth's clouds from outer space, this idea of NASA's mission to planet Earth kind of thing. And the National Research Council had a 50-year retrospect on viewing the Earth from space kind of thing. So yeah, I think it's a great idea. It's fantastic. There's weather and climate everywhere in the solar system, and everywhere there's an atmosphere anyway. And I think it's a great idea. The other idea was that the envelope of the solar atmosphere and the whole idea of the Earth's magnetosphere and the solar wind and all that, space weather, to put it in one little phrase, would be a tremendous way to write, not just for the public, but to get down but to do it as a professional, I'd have to figure out which warm people, stomp, I guess, which societal forces and which people and which observations and which models. So I think I might use that kind of approach, but it would take quite a lot of time to get it up to speed.
Okay, we got one last question for the day, and Dave wanted to know, at what age did you become interested in weather, and did a science teacher encourage you?
That's a great question. I lived on the Appalachian Plateau. It wasn't too far from Bedford County, Pennsylvania, and there's a very sharp drop-off in the Appalachian Plateau. And I used to watch these clouds seemingly build out of nowhere across the horizon, and gigantic cumulonimbus clouds. And was always in a way fascinated looking up and thinking about the but no, there wasn't. I had some good science teachers in high school. I had a really good chemistry teacher, but it was at Penn State when I was an astronomy major, and I knocked out the requirements in 3 years, and I was looking for something for my senior year. So I went over to this place called Earth and Mineral Sciences, and I studied with people like John Dutton and Hans Panofsky and became basically an atmospheric scientist in my fourth year, and then went off to Colorado State. And I just had some wonderful insights into how astronomy and atmospheric science were really closely related sciences. And I wasn't much of a forecaster, so that's why I worked on infrared and visible light transfer in clouds when I got to grad school. So yeah, and then the final thought was I then discovered I thought that about 3,000 or 4,000 people could do the things I was doing possibly better than I could. You know, they could integrate the equations faster, and they could fly in planes and take risks instead of me. And so I found a niche. I found a place in the history of science where there wasn't any history of atmospheric science at the time. That was in 82. And I jumped in there and I wrote a couple books and kind of, in a way, cultivated my interest and my niche there. And I'm very happy for that. So thanks for that question. It's really great. But it was mainly, I'm a real slow learner, so I think it was the third year of college I finally made the move.
Well, thank you. Thanks, Jim. I don't know if you guys can hear this. We've had the thunderstorm going on here with pea-sized hail bouncing back and forth during the presentation. The things are just, you may hear some, another lightning flash here as we talk. But we're going to.
Roz, isn't it? The hail, the rain, hail, and snow.
That's right. That's part of our network, and hopefully we've got a hail pad out there right now measuring. Again, it's just small stuff, but it's spring, and May is a time for hail in Colorado. So, well, Jim, thank you so much for taking time out of your day to be with us today. Fascinating presentation. We'll have this recorded and on the web for folks to view for future reference on that. And again, thank you. Now, folks, before you leave today, take the survey at the end of the webinar. That'll help our funders and our evaluators to know how we're doing on these webinars. Next month, just to give you guys an update, what's coming up on June 13th, so mark your calendars for Thursday, June 13th, Deke Arndt from NOAA's National Climatic Data Center will speak about monitoring the Earth's climate. So that should be an interesting webinar coming up. And then the following month, we're going to look at rainwater harvesting. So we've got if you go on our website, we've got a list of WeatherTalk webinars now through December. So again, hopefully you'll join us for another one. Again, Jim, thanks so much. We're going to sign off today, and this is Henry Regis from the Colorado Climate Studio wishing you a good day. Goodbye.
Thanks, Henry.